Good morning, everyone, and we are soon starting the program. As we know that we are celebrating the National Science Day event, and we have our distinguished guest of the day, Shri Dr. Shankar Nakhe sir. So please give him a big round of applause. We welcome you, sir, to the Nehru Science Center, and I request our director, Shri Umesh Kumar Rustagi sir, to please introduce Nakhe sir, and soon we will start with today's session. Thank you.
Good morning. Good morning and welcome to today, this very special day for all of us, particularly in India, because it's called National Science Day. And I think all of you are aware why we are celebrating. How many of you are aware that why we celebrate National Science Day? What is the occasion for that? Just you raise your hands. कुछ दिख ही नहीं रहे, हाथ खड़े हो थोड़ा ऊंचा करके, तो भीड़ में पता नहीं चल कुछ बहुत कम नाम सुनाई दिख रहे. Okay, that's why perhaps you are here. If you are you have heard about C.V. Raman sir. So the story goes like that. On 26th February 1928, he observed a very special research, you can say, or some light scattering phenomena. Then 28th February 1928, he announced it to the press that, okay, this we have discovered, and now we'll go for Nobel Prize. He was so confident that he booked the ticket for that, whenever they will be distributed or awarded. But in 1929, it could not happen, but 1930 it happened. He booked, next day also he booked the ticket, and now, you know, the science has done so much of good things for us. It has changed our life expectancy, it has changed our lifestyle, it has made our life so comfortable, so much of technologies they have been imparted. Nowadays we are using so many of gadgets. All these because of science, and science on its own cannot do it. Who does all these things? Scientists, engineers, technocrats. So it is time to celebrate their contribution. It is time to remind us that science and technology on its own will not come, but we need manpower, we need people like you, young budding scientists we call them. You get inspiration from that. We need to remind you that we have many more problems for which you all need to find some solutions for yourself to make life maybe better, to make life more comfortable. What you want for yourself, somebody else will not create for you. Okay, so that's how we celebrate, and we have already organized, I think last 1 week we have been organizing various programs. And today is a very special in the sense that every year we organize C.V. Raman Memorial Lecture, just to commemorate that famous discovery by Sir C.V. Raman, for which he got the most, or he got the most coveted prize in science, which every scientist maybe dream of, get the Nobel Prize. Okay. So, and we invite very special people, those who have contributed or outstanding scientists. We have with us Dr. Shankar V. Nakhe, who is first and foremost our executive committee chairman as well as our governing body member. He is a guiding force, we can say. I will briefly introduce you so that you can get inspiration. Dr. Nakhe is a distinguished scientist who assumed the charge of director of RRCAT, Raja Ramanna Center for Advanced Technology in Indore, on June 1st, 2021. from Shri Debashish Das, who superannuated in on May 31st, 2021. He graduated from Walchand College of Engineering, Sangli in 1985 with first rank in electrical engineering, which was affiliated to Shivaji University. Post that, he worked with Melton Semiconductors Private Limited for 1 year, and then he joined RRCAT after graduating from the 30th batch of BARC Training School. How many of you have heard about this? BRC Training School, which was started by visionaries like Dr. Homi Bhabha. It's like a IIT level training. Then you can join many of the big projects which or scientific institutions in India. Okay, then he subsequently obtained his MS Engineering Science from Indian Institute of Science, IISc Bangalore. Now it's called Bengaluru. At RRCAT, he has worked on design, development, and utilization of various laser and electronic systems. His main areas of work are high voltage pulse power supplies, electronic instrumentation, and control electronics for various laser systems. Many lasers and photonics systems developed under his leadership. They are being used now at various institutes. He played a key role in development of fiber grating inscription facility at RRCAT. This unique facility developed at RRCAT is being used for the development of specialized sensors for NIC application areas of temperature and strain measurement. He played a pivotal role in transfer of technology of point of care biomedical instruments developed at RRCAT. He took the leadership role in setting up the incubation center at RRCAT. He has served as General Secretary of Indian Laser Association and later as its president also. He has been confirmed with many awards, which include DAE, ESET Award and Best Paper Awards. He is author and co-author of about 60 peer-reviewed journal papers, articles in professional magazines, and about 160 conference papers. So, with such a large experience and heading, now he's retired. Just recently, he has superannuated from there, but still in this field, and with us also, guiding us still as a member of our governing body, what we should do, what we should not do. With this brief introduction, I would request Dr. Nakhe to come on the dais. Sir, please. And I will also request Ms. Ovi Bhamre from IESVN Sule Guruji School. Sir. Yeah, Ovi will welcome Dr. Nakhe on behalf of all of us by giving this potted plant. That's how we welcome our guest. And with this, I will request Dr. Nakhe to take over and inspire this young gathering, young budding scientists, I should say, so that we can get more manpower or force to work in our scientific institutes. Over to you, sir.
Good morning. So my presentation will come in between. Just I would like to interact with you. How many is anybody having birthday today? This is a very special day in the audience. By chance? Okay. So this is my presentation today. I'll be giving a lecture and taking you to the journey of Raman effect, right from 1928 to till date. So this is almost a journey of 100 years, and in 100 years, as you know, many things get wiped off and out of our memory also. But this is Raman effect is such a fundamental and impactful discovery that still it is going on with full-fledged, and many applications are coming up. So it will be very interesting to know on this. So, and as you know, this year's, I'll come to that. So this is my presentation, brief outline. So I'll give some background of National Science Day. Our director here has already given, but I'll add some more things to that. And then we'll go to some of the glimpses from Professor C.V. Raman's life, and that are very important for us, and the learnings are very important and significant even today. Then some Raman effect basics, evolution of Raman effect applications and its avenues for Raman effect in Viksit Bharat. That's what we are talking for. And we all look forward to the young generation to take India ahead and make our nation as a developed country. So there will be some points which are to be remembered, and I'll emphasize that again at the end of my lecture. So as said earlier, and Rastogi Sahab has said, so this discovery of Raman effect on 28 February 1928 we selected as a National Science Day on recommendation of National Science and Technology Commission. It recommended to Government of India, and 86 it was recommendation, and from 1987 this National Science Day is in action, and from 1999 each year a very specific theme is assigned, so that all these celebrations will be in particular direction and orientation. So this year's theme is, as you know, the theme highlight empowering Indian youth for global leadership in science and innovation for Viksit Bharat. So this theme highlights India's dedication to fostering youth. I'm sure you will be entering that phase very soon, or some of you are already here in that phase. So potential in science and innovation, and aimed at creating global leaders who contribute to the country's goal of becoming a developed nation. I just read out what is this year's theme, and I'll come back to this slide again at the end of presentation, so we'll have more impact and what is importance of National Science Day. So let us go back to Professor C.V. Raman's work. And what we have to learn from his life is silent features. One is hard work, positive outlook, and confidence. I'll give small stories for each of it. See, C.V. Raman was a child prodigy, and he was born in Tiruchirappalli in Tamil Nadu. And he has done his school education completed at the age of 13. At the age of 14, he was a college student, even at those days. So where many times students used to enter school at the age of 9 or 10, but he has already passed out. He was such a talented person. Of course, talent and intelligence is a God-gift thing, but he utilized it very carefully, craftedly, and with hard work. He has very positive outlook towards life. I'll highlight that. See, he was such a brilliant child, and at that time, the most challenging or say demanding career for such children was to join Indian Civil Services, which is comparative of IAS as on date, but it was still much more prestigious because the selection was very tough and very limited persons were allowed to go there. So he was confident that he can go there, but at the last moment when he was to pass out for the medical examination, the civil surgeon of the Madras zone said that no, this child is not fit and he cannot go to England, he cannot tolerate the journey, and he will have problem. So see, such a gifted child was denied admission to ICS just because of whims of a civil surgeon there, who was Britisher of course, and he has to stay back. But he never lost his aspirations, and he joined finally Financial Control Services of that time, Financial Civil Services, and at the age of 19, he joined as Assistant Accountant General of India at Calcutta, because Calcutta was a major city at that time. And at the age of 19, this child shifted from Chennai, that is Madras Providence, to Calcutta and start working for Government of India at that time. So it was a very prestigious job, and he has that type of positive outlook and confidence in all his work. As indicated earlier also by Rastogi Saab, when he declared the discovery of Raman effect, he was so confident that he will get Nobel Prize for the same. He booked tickets in advance, even for this ceremony, to join this ceremony at Europe. So such a life, he has that confidence towards his life, all his research work. And he was totally dedicated to science. So even though he was working for Indian civil services or equivalent of that, FCS at that time, but he was very much interested in science. And while on his journey from his residence to office, he one day saw a board at Indian Academy of Association for Cultivation of Sciences in Calcutta. And he got curiously interested, what is this? What science they are doing? So he went into that building, and you must be knowing, you might have visited the exhibition here, and he started working there as a scientist also. It was a very dedicated institute, but not in very good shape at that time. But he joined there, and before office hours and after office hours, he used to contribute in science research, discoveries, etc. So that was his dedication to science, even at the young age of 19 or 20, I would say. And subsequently, when he come again as from transferred, he was transferred to Rangoon, to Nagpur, and then again back to Calcutta, and he was working there. At that time, once he got so much interested in science, so the Calcutta University vice chancellor at that time, he said that, why don't you join this university and be professor here and give yourself full time for the science, because he was such a talented person. You may wonder, at the age of 18, he published his first research paper in the area of physics in Philosophical Magazine of London at that time. And that work he has done alone on his own at Presidency College, Chennai. So such a talented person was he. So again, coming back to dedication of science, when he was working in FCS, he decided to resign that very prestigious job and joined almost half of the salary and leaving all the prestigious, or say, so to say, very boastful benefits of government service, even at that time of that British service, and decided to join this science. So he was so confident and dedicated to science, so that he will take these things ahead. Along with this, he was very much interested, and he had a great respect for our Indian art and culture also. So I'll come to some slides there just after this. But he had, in spite of having science, a person of science, he had dedication and respect for culture and art. You must be knowing, as stated earlier, when he was there for the Nobel Prize, he was wearing the typical Madrasi turban there also. He has not gone into a very European costumes, but he was still loving that. Then he was into building world-class scientific institutions. As said earlier, this Indian Association for Cultivation of Sciences was an institute which was dedicated for science at that time, but it was in very bad shape. But once Professor Raman joined there, that institute was buzzing with scientific activities, and very soon it became so prestigious that Calcutta appeared as a prominent science city on the world map. So after this Academy of Sciences, he established Indian Institute of Science, Bangalore. He was there as a director, and after that, he himself established Raman Research Institute at Bangalore. So he was very much into building world-class scientific institutions, and he was a scientist of such a high caliber that on his invitation, very eminent scientists from Europe, they came to IISc Bangalore and worked here. You might have seen the movie Oppenheimer, many of you. And that Oppenheimer's guide, Max Born, he came and worked at IISc Bangalore on invitation of Professor Raman. Such was his reputation and his dedication to building scientific institutes, because he wants that he was interested to have world-class scientific institutes in India, because he wanted India to be the world-class nation. That is what we call today a Viksit Bharat. And he was very much in science popularization. He used to give very popular lectures, bringing science down to the understanding of students. He used to give lectures with very interesting demonstrations. And the first scientific discovery which India got the Science Nobel Prize, he demonstrated very well in a lecture at Bangalore and Calcutta also, with his own experimental setup. So this was a life of Professor Raman, and which we should recall today, and those who are interested in science should definitely dedicate. See, he was such a renowned scientist, and he would have got jobs, and he was having very prestigious offer for him to work in Europe and US, but he declined all those, and he worked in India, and rather he invited prestigious scientists from other countries to make India great, and the building world-class scientific institutes here. Raman effect we all know, but his other works we may not be knowing. And as I said, he worked very greatly on science of Indian musical instruments, and particularly percussion instruments like tabla and mridangam. People say that Western drums are also there, but he categorically brought out why these Indian instruments are so sweet and so superior. And he worked on these modes of vibrations on these instruments, and it was a very detailed mathematical analysis, and he published many papers on this, and these are world-class papers still today. And these are the different modes, and this is an experimental work. As you see these white lines, these are actually very fine sine lines. They are sitting there, and as this drum vibrates, these are the lines where there is no oscillation, and this is subsequently proved by advanced mathematical simulations at this stage. And this was another area where Professor Raman has worked. His dedication to art, I would say, I give another example. Here, this is a portrait of C.V. Raman, and those who had keen observation can see here what is written here. Can you notice? Anybody of you, particularly front runners, can you notice what is written here? Normally artists write their name or sign. This is Homi Bhabha. As you must be knowing, Homi Bhabha was a great artist also. He was great painter, architect, and this was a painting of C.V. Raman, who gave shelter to Dr. Homi Bhabha when he was here during Second World War, and he nurtured Bhabha's talent further. And as you know, Dr. Bhabha established subsequently Department of Atomic Energy, and even Vikram Sarabhai, who established Department of Space, which is a world-class institute even today. So when Bhabha made this painting and gifted it to C.V. Raman, written that this is scientist painted by a scientist, then Professor Raman immediately reacted that no, it is an artist painted by an artist. So this was such his respect for art throughout his life, in spite of being a Nobel scientist and of that caliber. So now, with this, we'll move to little bit of science now, with the background of Dr. Professor C.V. Raman's life and what was learnings from that. We'll go light, as you must be knowing, you must have learned in your scholastic studies. Light is an electromagnetic radiation. But electromagnetic radiation, as you see, is a very vast spectrum, right from radio waves, microwave, infrared, visible, ultraviolet, X-rays and gamma rays. And these are the wavelengths and these are the frequencies. And what we call as electromagnetic radiation, that is visible to human eye, that is typically from 400 nanometer to 700 nanometers. So that is the light spectrum of electromagnetic radiation. And again, very briefly on this. So light has some important parameters. It has certain wavelength or frequency as indicated in earlier slide. Then it has a spectral content. When you see a band, there can be different spectral contents. Then it has a polarization also. As said, it is an electromagnetic wave with electric field and transverse magnetic field. And this radiation is going into the board, so that's why this cross mark is indicated here. And it has some special qualities also, that is its mode, that is TM mode, how very well focused it is. So there are qualities which are defined by this special quality. And light is represented either as a wave, as you know, it is transverse wave with orthogonal electromagnetic fields. And light is also represented as photon, that is a quanta of energy. So it is a wave as well as particle. So this is a unique quality of light. So it has both this nature, and it depends on which type of effect we are looking. So it manifests either as a wave or particle. And how it interacts, light interacts with matter. So there are different interactions, as you might have studied in your physics lab, particularly 8th class students or onwards, you must be remembering your experiments. There is a transmission, absorption, and reflection of light from a surface. And there is another effect that is called as scattering. That led to the Raman effect or Raman scattering. So before that, there used to be a Rayleigh scattering. As you must be knowing, Raman effect is broadly known as, people say that sky is blue and that is the Raman effect. That is what is general notion of Raman effect, but that is not correct. Sky is blue, that is because of scattering, that is correct, but that scattering is called Rayleigh scattering, and that was discovered by Lord Rayleigh, and it was very well established much before 1928. So it was categorically different. But what Raman worked was why the seas are blue. So it was earlier a conception, or I would say misconception, that it is a sky that we are seeing from this seas reflected, and that's why the seas are blue. But then Raman worked very hard on that, and he demonstrated that it is not the reflection of sky, but it is a totally different effect, and that is why it is not again a Raman effect, it was a different type of scattering. We'll come to that slightly later. So there is a categorical difference in Rayleigh scattering, fluorescence, and what at that time was called as a feeble fluorescence, and this is actually a Raman scattering or Raman effect. So this has a polarization maintenance, and there is a change of frequency or wavelength. So that is the Raman effect. So this is Raman effect, and if you see literature or websites, you will see many words along with the Raman. Either it is Raman scattering, Raman effect, or many times Raman spectroscopy. These are the words which are commonly associated with Raman effect. So let us see what is this. If there is a, say, liquid particularly, and there is a excitation light or incident light of particular wavelength, then either it will get transmitted, but part of it will get scattered, which is called as Raman scattering. And Raman scattering has two parts. One is either Stokes scattering or anti-Stokes scattering. In anti-Stokes, the excitation wavelength is greater than the emission wavelength. So this is anti-Stokes scattering. It is still weaker than the Stokes scattering. Either it will get elastically scattered, so there is no change of wavelength, or there is a fluorescence. You can see fluorescence. You know, fluorescence dyes. All our clothes are, or wherever color is there, it is because of fluorescence. And there is a Raman scattering, which is a dominant Raman scattering, that is a Stokes scattering. So if you go slightly detail into physics, I will not go much into physics part later, but if there is a molecular vibration and there is a incoming radiation, it may be, nowadays it is mainly because of laser, then you will have a Raman-Stokes scattering here. So this is these are ground levels, these are virtual energy levels from where these molecules are excited and they give the come back to original state, and there is a Rayleigh scattering. But if they are not coming to the ground level, but they are coming to some other level, or they are coming from still higher level to the other level, there is a Stokes scattering where the wavelength is longer, and anti-Stokes Raman scattering where wavelength is shorter. So this is a total Raman effect. And coming back to the instrument, because you are from 9th, 10th, I suppose, and not higher than that, most of you. So I'll give you this, again we'll come back to the Raman's history, Raman effect history. So this original Raman spectrometer, where spectrometer, what it does, the light, different colors of light are sprayed on a spectrum and they are shown at different places in this spectrometer. So this is called as the spectrograph, because this instrument is dividing the colors and showing it at different places. I'll show it in a moment later. And at that time, Raman used solar light as a source, and through telescopic arrangement, and there is a very ingenious arrangement that is called heliostat. So even if the sun position is changing, you can get radiation at that same spot in your experimental chamber or experimental cell, I would say. So this was a very ingenious arrangement. Can anybody think of it here? This is an arrangement made 100 years back, and we say we are very much advanced. Can anybody of you devise such type of arrangement? Those who are consider themselves science genius, try it in your school, and maybe you will get a prize for that type of arrangement. It is a simple mechanical arrangement which tracks suns. Nowadays solar panels are also tracked to have maximum efficiency. You can try it later, think over it. So this was a simple instrument, spectrograph, at that time, and Raman's demonstrating his effect in laboratory to foreign visitors and in his lab along with Krishnan. So this was a demonstration of Raman effect, and at that time the spectrograph, the detector used was human eye. Raman has seen the effect with his own naked eyes and in his laboratory. His observation was very keen, and otherwise it requires a photographic film. Now photographic films are not used normally. Now there are very sensitive CCD detectors, you know, CCD cameras. But this was a Raman spectrum which was published along with the original Raman paper which he got Nobel Prize for. And you must be knowing, the science was so competitive even at that time that within 3 months, when Raman submitted his paper and it got published, there was independent group working in Russia and France. They submitted similar work, and they were trying to claim that they have done it for the first time. So science was competitive even at that stage, and it is still today. So that's why confidence and hard work is required, and that is what is the learning from Raman's life. So nowadays what you see, the typical Raman effect will be, there will be a light source which is nowadays laser. There will be a filter with which a particular wavelength is incident on sample, and sample gives back light, and out of that certain wavelength is to be detected by spectrometer or detector. And this is a Raman arrangement, and this is called as the Raman effect or Raman spectroscopy. As I said earlier, most part is Rayleigh scattering, and out of that, still 1 in million is Raman scattered. Such a weak is Raman scattering, and the Russian group that I mentioned, they took 15 hours to record the data on photographic film. So it was not possible to detect as such. You may wonder why this is so important. It was a great curiosity and a very fundamental research. Every year, almost 200 research papers were getting published, even after 1928 till this 1960, every year in international journals. So that is the impact of Raman effect on fundamental science. And once there is a laser that came into picture, so the intensity of this laser source or light source increased manifold, and that got into the practical applications, real life applications of Raman effect in our day-to-day life. So after 1960 till date, almost 1,000 research papers are utilizing Raman effect every year. So that is the impact of Raman effect even after, I would say, nearly 100 years. So laser has a big impact, and advanced detectors, earlier as I said, only eye was used as a detector, then subsequently photographic films along with that, and with detectors now, CCD cameras and advanced detectors, we can detect very feeble light, or even now detectors are available which can detect a single photon, which means we can detect a single molecule in a sample. So this is a great advantage and for many scientific areas. So as I said, something about laser, and this is my favorite work area, so I'll give just small introduction of laser and why it is so important. In laser, there is a lasing medium where we get population inversion. This can be gas, solid state or liquid state. And we excite this lasing medium with pump source, and there is a special optical arrangement called resonator from which we get a laser light. So this property of laser light is it is highly monochromatic, so its intensity is much higher. Even 1 milliwatt of laser, so this pointer that you are seeing is not actually a laser, it is a laser like, but if you see its brightness, actual laser brightness, it is at least 1,000 times brighter than the full noon sun brightness. So that is the 1 milliwatt laser brightness. And nowadays lasers are available which can go up to 1,000 watts, kilowatts and still higher. So you can imagine. And much more than that is it can be focused to a very tiny spot. So laser intensities are such high that they can cut stainless steel of maybe 10 centimeter thick without any problem. So the earlier, as said, it was very difficult to see the Raman effect, but now with introduction of laser, this is a typical demonstration that we give in our laboratory at RRCAT. Here you can see the benzene cell which gives Raman radiation or Raman effect. So here you can see the Raman radiation which is much brighter and you cannot see it with naked eye. This is a special photograph taken, and that is the high power of laser that earlier were to detect the laser radiation, sorry, Raman radiation or say Raman scattering, you have to wait for hours to record the data. The radiation is so strong that you cannot see even with naked eyes. And with now laser diodes and sensitive detectors, the Raman setup is now very compact and it can be fitted into a device so small. So where we are leading now, I'll give some effects. So how we are seeing how the lasers, Raman effect, detectors, how we are progressing further and introducing or say improving on the science. So there are many areas because of which the basic fundamental science discovery of Raman effect is getting better and better day by day. So there is a light source which is laser. Lasers are improving. There is a sample handling mechanism. Here a lot of mechanical engineering, chemical engineering is involved. Then there is a signal enhancement. Again here there are lot many mechanical engineering and advanced scientific things are involved. There is optics, again very specialized branch of engineering. Signal processing, this is effect of electronics. There is a detector, data processing. I'll come to this slide once again later. But all these improvements on this, and I have purposely kept this number restricted to 7, as we know 7 colors of light. So all these disciplines are improving the utilization of Raman effect and its application. So we'll go through the history very briefly. Of course, it is not very precise and written year by year, but some highlighted points are there. So Raman's effect, as said, it is not that Raman has seen it on one day and because of his confidence, he declared and it was that. He was working on this phenomena for 7 years. Right from 1921, he was working very hard on this and going into the details of it. You may remember, or say I'll give a story. When he was coming from his Europe tour in 1921, he got interested into the blue color of sea, and that was at that time there was no air travel. One has to go by ship only. He was coming through ship, and ship, it is a very boring and tiring journey. So ships used to stop at certain ports, and the passengers were made free to touch the earth and enjoy some life at the port and come back again. So when all other passengers, it was a SS Narkonda ship, and it was coming back from Europe. So all passengers were going and enjoying at Eden. But Raman, during this 7-8 days tour, has extensively studied and spectra from seawater and other effects. And when the ship stopped at Eden, he posted his research paper that he has written himself on ship. And at Eden port, he posted his research paper to the editor. And so he was so passionate, so hardworking, and so dedicated to the nation. And from Eden to Mumbai, it took again 8 more days. And during these 8 days, he again contributed. He worked hard on it, and he posted next journal paper when he landed at Mumbai airport. He has done that job first, and then back to Calcutta. So that was his hard work and dedication to the science. So to say, the Raman effect was not a one-day discovery. Of course, it happened, and it was declared on that day, but there was a very hard work that was going on this effect. Then there were extensive Raman studies using Raman effect, 1928 onwards. As I said, there were hundreds of research papers that are going on. Then there was an instrument called monochromator was invented in 1960. So that made detection very convenient. And then Raman grating spectrometer was invented. Then there are many phenomena, particularly laser invention was there. And then commercial Raman spectrometers started coming in even in 1953 when these advanced detectors were there. And once this laser invention is in place and laser devices started coming up, there were many areas where the things are going on. I'll elaborate on that subsequently. But there is a special thing called Raman laser also. You may, if you Google it, you will see something like Raman laser. It is very advanced phenomena where you don't require what is popularly known as a population inversion, but it is a different phenomena. This is also very useful. And there are many advanced techniques. CCD detectors come, they are combined with Raman spectrometers, and then Raman spectrometers become very compact, and they are used in very many applications. Then now even live cell studies can be done using Raman, and there are many applications of Raman in defense, space, and now buzzwords of today, that is AI and ML techniques, are extensively used with Raman spectroscopy for advanced studies. So these are the different Raman spectroscopy techniques. I will not elaborate on that. I had just listed 8 of tests for your information, but there are at least 25 Raman spectroscopy techniques which are used in very applications. So one is conventional Raman, where the spatial resolution, that is the sample size, is typically 1 mm square. When you go for a surface enhanced Ramas, the signal is amplified almost 10,000 to 1 million times. So these are very different Raman effects that are used in life. And this simple instrument that was used earlier, that is a sunlight filter and detector, now advanced Raman instruments are like this, and they are used in very many applications. Now what is its relevant to Viksit Bharat? Can you think of what is required for Viksit Bharat? Which areas are required? Anybody? Where would like to be there? Our Prime Minister says that we should be advanced nation by 2047. Yes, what is your idea of Viksit Bharat? What would you like to have? SDG, environmental goals. Yes, very good. Any more from front seaters? Yes, please.
So, Viksit Bharat, it should basically end the poverty, world hunger, and the whole country of India. It should be green like before.
Yes, very good. Anybody from this side? Those who are laughing, you have any idea of Viksit Bharat? You have anything to contribute? No, nothing. Yes, self-reliance. In which areas? Self-reliance in which areas? Atmanirbhar Bharat we are talking for many years, isn't it? And Raman has started even at that time. Yes, please. You have to say something. Environment. Stop pollution. Yes. Cleanliness. I think mostly you are concentrating on environmental. Yes, please. Fine. Any area apart from environment? Any other areas?
Progressive in the field of technology as well.
Yes. Yes, please.
Economic stability.
Economic stability. Yes. Yes.
Better infrastructure.
Infrastructure. Who is interested to join defense? Armed forces. Anybody? Yes. Yes, you can tell. Fine. So, I listed some of this. So now you know India is very much into that semiconductor industry. Somebody has said economic development. It is said that now the semiconductor chip is going to be a major economical driver for decade to come, and I think many of you should contribute in those areas. Defense and homeland security, that is internal security. Health for all, societal health, medicines, space technologies, environmental sustainability, and quantum technologies, quantum communication, quantum computers. All these are areas which are very much required and where we should be self-reliant when we are moving to Viksit Bharat. And keep it in mind very well, in all these areas there is definite application of Raman effect that is going on right now. I am saying, and you can take it advance it further, and make it Viksit Bharat, because today's demographic advantage is there and it has to be utilized, otherwise will not be moving further. So I have given just small examples here. I will not go into much of elaboration here. So I had said pharmaceutical industry. What can we do in pharmaceutical industry? We can study the distribution of compound within a tablet. we can go for high throughput screening. We should have a very good quality of every product, every medicine, every tablet. Can we do it? Can we examine it? Raman effect is there, it can be done. Can we study the concentration of API? API is active pharmaceutical ingredient. So can we study that? Can we ensure raw material quality? We study or say we come across that raw material is of not proper quality. So Raman effect is there. So in vivo analysis, it can be done. And various chemical combinations, those can be studied. So these are very many areas in pharmaceutical industries where Raman effect is being used and it is advancing further. So this is just example. This is a tablet where laser is input, and what is inside tablet that can be studied. There is a transmission Raman, there is a Rayleigh scattering, but what is inside capsule can be studied using Raman effect. So in societal health, we can use for cancer detection, TB diagnosis, Alzheimer, hepatitis, and many others. So there are international leading analytical instruments company which are coming out with their own products using Raman effect and utilizing it for such applications. And coming back to applications of Raman in defense and homeland security, development of nanomaterials for stealth coatings. How many of you heard of B-2 aircraft? So what is its speciality? Yeah, and that is because of stealth coating, and Raman effect or say Raman spectroscopy is very much used in developing such stealth coatings. Then there are reduced IR signatures for high impactful missiles. It should not get detected by enemy radars. So again there are special materials for that. Then there are environmental resistance and durable materials. As you know, our army is deployed at temperatures where it is less than -40, and at other season it goes at places more than 50. So the materials are in the open air. They have to face very harsh environment, so they have to withstand that. So such materials can be developed. Then you can have analyzing explosives and submarine leaks. That is also the area. You must have seen at airport, those who have traveled there, or even at VIP entries, there are some special detectors are used to detect these explosives or even narcotic materials. And in advanced warfare, there are chemical or biological warfare are there, and these agents are sprayed. So Raman effect can detect those. So this is a work by Indian scientists to detect the hidden narcotic material or explosive. So this is by Shiva Umapati, who was till recently a director at ISR Bhopal, and he was earlier at IISc. They have developed this instrument. So such a work is going on in our country in a big way. In our center, we have developed instruments based on laser and Raman spectroscopy to detect TB at very early stage and cancer at very early stage. So these are some of the instruments that have come up because of our research in the country. This is from some defense lab that has worked, and this is developed by a company called New Age Instruments and Materials Gurgaon. So those who want to have startups, new age companies based on deep technologies, there is a lot of scope utilizing Raman effect and advanced technologies. There is another company which is called Research India Bhopal. They are coming up with various Raman spectrometers for various real life applications in advanced technology areas. So with this all advanced instrumentation, I come back once again. This old spectrum, which was recorded on a photographic film, which took very long minutes, and in Russia it took hours. But this type of sharp spectra can be recorded within no time, less than millisecond, with advanced instrumentation. Such is the progress. And now with all this background, again you look at this year's theme, I think you can now correlate it with empowering Indian youth, that is those who are at that age, maybe those who are talented, who are dedicated, who want to come ahead for global leadership in science and innovation for Viksit Bharat. So Raman effect is still very relevant, and if India has to go to this Viksit Bharat stage, so we have to use this science and innovation and we can move ahead. So this was the theme of this year, and I think with Raman's life, his work, and how it has progressed from I would say his studies from 1920s to now more than 100 years, we're in 2025, where we have reached. So again, coming to learning points from this, fundamental science discoveries have deep and long-term impact. That is very clear from Raman effect. Can you name another such discovery or say invention in science which has a long effect, very deep effect in our life, which is contemporary of Raman effect or subsequently? Anybody? Have you heard of X-rays? You might have faced those who have fractured, MRI, any other scan. So X-ray is such a discovery that has such an impact. Raman effect has this impact. So science has such an impact that it fuels many engineering disciplines, technologies, and life. So they are aiding each other. This is positive feedback and improves your human life. As I stated earlier, Raman effect is in semiconductors, optics, AI ML is now improving, and in turn, due to quantum technologies, AI and ML is also improving. So there are materials for renewable energies where it is there. So again, coming to Viksit Bharat, we should understand that deep technologies is the bedrock, not just fast food delivery is not the Viksit Bharat. It is moving economy ahead, but there is some fundamental again science that is going back in their computer softwares, etc. So homegrown technologies in critical areas are essential. Otherwise, one fine day US will say will not give you the engines, will not give the materials, medicines, and we'll be nowhere. So we have to have homegrown technologies in critical areas, and youths, that is you, have to take this indigenous technologies ahead and in a big and impactful way. And there are guidelines available, beacons like Raman are there, and there are many other scientists. So I'll at the end of my lecture, I'll just highlight few points. This I used to highlight. How many of you know this person? Is Vikram Sarabhai. Our space program is one of the best in the world nowadays. It is because of his leadership. And he has said, when he has said this, it is in 1969, UN, that we must be second to none in the application of advanced technologies to the real problem of man and society. Then you know this person, many of us must be knowing, Dr. Homi Jahangir Bhabha is one of the best scientists of India in nuclear energy, and he established Department of Atomic Energy, and Department of Space is outcome of that. He has said clearly that if an Indian industry has to take an independent flight, it must be powered by engines of indigenous technologies. Otherwise, will not be there. Many of you might have seen the air show at Bangalore, either in person there or on videos. There are reels and movies available on that. You can see the power of those. But if you have to have our own aircraft industry, it must be based on our own technology, and it has to be taken ahead. So again, coming back to Raman once again. So he has said that success can only come to you by courageous devotion to the task, let it be science or any other, and we need a spirit of victory, otherwise we'll be just contributing. We'll be working for some other foreign firm, Google, Amazon, will be contributing for their software development, but they are taking benefit. They are becoming advanced nation. There is some motivation to our economy, but we are not becoming Viksit Bharat. So we have to have that spirit of victory, and that will come by our dedication. So again, Raman constantly reminded us of our strength. He deserves to be referred for his scientific accomplishments, and more than that, even today, we need to honor him even more for his fighting spirit that we must imbibe and move ahead. So let us do our best for the Viksit Bharat. There are a lot of green pastures ahead in which we have contribution. If there is question, with permission of organizers, I'll be happy to answer. Or you can keep on visiting Nehru Science Center. There will be a lot of your curiosities will be addressed.
Having questions or question, we can quickly take a couple of them because we have to wind up maybe by 12:25. We have another event, inauguration of an exhibition. So we'll go there. So, on this side, who will ask the first question? Yeah, from front row. No? No question. On this side, no? So this hand or it's something else? Okay.
Thank you. And I once again thank Nehru Science Center staff and officials for organizing this National Science Week and toiling very hard to this noble cause of science popularization. Thank you. Thank you. Congratulations.
Thank you, sir. Thank you for the wonderful information and sharing us the concept of Viksit Bharat, which we are all looking forward, and how we can achieve it. I think this is the young force who are sitting here. Some of you, he has already mentioned about Homi Baba, sir, Vikram Sarabhai, C.V. Raman. They are the leading, the guiding scientists, you can say. But if some of you, that's why we organize this program, that at least one or two of you can get some inspiration and do something. Because after 1930, we are still, as Sir has said, we are still looking for another Raman or a Nobel Prize. Despite it's now almost close to 100 years, maybe 5 years from now, 6 years from now, it will be 100 years. But we are still looking for that. So all the best for all of you. Do something. Not only for Viksit Bharat, maybe another Nobel Prize.